one of the oldest and smartest things humans have ever built. But did you know there's more than just one kind of bridge? In fact, we've created all sorts of bridges designed with a specific purpose, location, and an idea in mind. From the simplest wooden plank to massive steel giants that stretch across seas. In today's video, we are going to be breaking down every kind of bridge explained in under 10 minutes. So by the end of this video, you'll be able to determine which is which. Let's get into it. Let's start with the beam bridge. The beam bridge is actually the simplest of them all. Imagine you're laying a wooden plank across a small stream. That's a beam bridge. It's just a horizontal beam resting on supports at both ends. When a vehicle drives over it, the weight pushes down in the middle, and that force travels to the ends where the support takes it to the ground. They are quick and cheap to build, but they can't span very long distances without more supports in the middle. You see them on highways and overpasses or even small rivers. Now imagine that same beam but reinforced with a web of triangles. That is a truss bridge. Triangles are one of the strongest shapes in engineering. They don't bend easily, and by connecting steel or wooden bars into a triangular framework, truss bridges can hold more weight and stretch longer than a plain beam bridge. You also find them on railway lines or old industrial routes. They may not look flashy, but they are strong and efficient and built to last. Next, we call things a little with the arch bridge. The arch bridge is dated to the Roman periods, where there are Roman aqueducts or ancient stone crossings. Its curved shape takes the weight from above and pushes it outward towards the support at each end. And these types of modifications are called abutments. That is what makes it so stable. Modern arch bridges are made with stone, steel, or concrete. They are great for valleys, rivers, or places where a strong foundation can be built at both ends. Okay, let's up the scale a bit to suspension bridges. Suspension bridges are like bridges that are hanging in the air. Well, kind of. Here, the road or the deck used is suspended from massive cables which hang from tall towers. These cables can carry the weight of the bridge to the towers, which then push it into the ground through strong foundations. Suspension bridges can span huge distances, which is why you see them over wide bays and what they call straits. An example is the Golden Gate Bridge. The cable-stayed bridge is like the cousin of the suspension bridge, but instead of cables hanging freely across towers, here they go straight from the tower down to the deck. So this design gives it a clean, sharp look, and it's easier and cheaper to build for engineers than a full suspension bridge, especially for medium to long spans. For example, the Millau Viaduct in France, which, as you can see, it is super sleek, super strong, and that bridge is not going anywhere. A cantilever bridge is built using arms or obviously cantilevers that extend out from piers. Each arm supports part of the bridge and sometimes they meet in the middle. A classic example is the Forth Bridge in Scotland. It is huge, red, and made entirely of steel trusses. Next, we have the tied arch bridge, also called a bowstring bridge, and this mixes the idea from arch and suspension bridges. You've got an arch above, but instead of pushing outwards like a regular arch, the ends are tied together by a horizontal beam that takes the force. So this makes it ideal for places where strong side supports aren't possible. They look beautiful and work well. They work really well for both roads and rail bridges. Movable bridges aren't fixed at all. They have different designs based on the engineer's perspective, and they are designed to open or lift when boats need to pass through. The movable bridges are a bit complex, but they are useful in busy ports or old city canals. A good example of a movable bridge is the iconic Tower Bridge in London. A less common but super smart hybrid is the Extradosed bridge. The towers are lower than in a typical cable-stayed bridge, and the cables help support the deck without needing big arches or towers. It's efficient, compact, and ideal for cities where space is tight and you still need strength. Besides your normal structures like the skyscraper, bridges are grouped by what they carry. For example, road bridges are for cars and buses, rail bridges are for trains, pedestrian bridges are for walking or biking, aqueducts are for water transportation, viaducts are for crossing wide valleys, and even pipeline bridges are for oil and gas. Each bridge's structure depends on its purpose. A footbridge might just be a beam. A train bridge needs way more strength, so you often see trusses or arches. Okay, final thoughts. All bridges, no matter how different, are trying to solve one big problem, and that is getting people or things across a space safely and efficiently. And the way they do that depends on the distance they need to cross, the weight they need to carry, the land or water underneath, and the budgets and materials available. That's why engineers don't just choose a bridge type because it looks cool. They choose it because it works best for the job. So next time you walk or drive across a bridge, look closer. Try to guess what kind it is, because now you actually know. So that's it, guys. If you enjoyed this breakdown, drop a like, hit that subscribe button, and share this with someone who thought all bridges were the same. Thanks for watching, guys, and I'll see you in the next one.